Right. Hello, Algebra 2. This is our first instructional video, so I thought I would wake you up with a nice math joke. Here we go. Why shouldn't you let advanced math intimidate you? Well, it's because it's as easy as pie. Ba-dum-bum-ch. All right, enough of that. If you could go ahead and take out either a blank sheet of paper or your copy of the blank unit circle. I know we did this on the last day of school before spring break, but I thought kind of as a transition into home-based learning, we are going to go back through the unit circle with the intention of we've got to memorize the degrees and the radians of the special angles, and then we also need to memorize the cosine and sine. So if you are an expert, you can probably skip this video, but I would highly recommend that you go ahead and follow along with me. So if you have a blank sheet of paper, go ahead and draw the unit circle. Here it is. Okay, this is what we did before break. And we're just going to walk through it one more time as kind of like a wake-up call as to what we're going to be doing and using the next lessons to come. So, if you recall the unit circle, the 4 axes points are very important. So we know that we start at 0 degrees, and then a semicircle is how many degrees? 180 degrees. And then we have a half of 180 degrees. 180 divided by 2 is 90 degrees. And then if we scroll down and we add 90 to 180, we are going to be at 270 degrees. Okay, so from there, we add 90 more, and how many degrees are in a full circle? All of us know this from geometry. We have 360 degrees. So now we can go ahead and think about the radians of these angle measures. So if we go ahead and look, okay, we know that 0 degrees is nothing, so therefore we have 0 radians. Now, how many radians is a semicircle? A semicircle is pi radians, okay? So that's like a key that you just kind of have to use to start figuring everything else out. So then if we see that one semicircle is pi, if I put 2 semicircles together, what do we get? We get 2 pi. Okay, now if I backtrack and I look at my first semicircle and I think about my semicircle cut in half, all I'm going to express is what would I do to pi to cut it in half? I would divide it by 2. So we have pi divided by 2. Okay, and then we can do the same thing in the bottom 2 quadrants, but we could also count by pi over 2's. Okay, so you have 1 pi over 2, 2 pi over 2's is pi, so then down here we have 3 pi over 2's. All right, so that's what I would fill out first. Now from here then, let's kind of go back and let's think about slices of pizza in the first semicircle. So we're going to go back to degrees and we're going to think about what are the special angles that we learned in geometry. It's 30, 60, and 45, but you have to put them in numerical order. So we have 30 degrees, we have 45 degrees, and we have 60 degrees. Okay, now normally I leave that 45 out, but I kind of wanted to show you that first quadrant because we reference it so often. But now I'm going to leave the 45 out, and I'm going to count by 30s. So I have my 30, I have my 60, I have add 30 to get 90, add 30 more to get 120. My 2's are really bad on using this stylus. 120, add 30 to 120 to get 150, but again I skipped that 45 slot, add 30 to get 180, continuing on, we are going to add 30 to 180, and we get 210, add 30 to 210, 240, add 30 to get 270, which we already have, Then we have 300 when we add 30. And then we finally have 330 to get us to then our final goal destination is 360. Okay, now we need to go back and we need to work separately with our 45s. But remember, our kind of 4 axes are involved in everything we do. So now if I start with my 45, I add 45 to get 90. Then to 90, I add 45 to get 135. Or you could look at adding 15 to 120. Either way. Add 45 to 135 to get 180. Then add 45 to 180 to get 225. Then add 45 to get 270. Add 45 to get 315. So there are the degree measures. Okay. Now, after this, what do we need to do? We need to go back in and add our radian measures, which I've been putting in blue. Okay, so if we look at our 30 degrees, okay, we have how many 30-degree angles in the first quadrant? I'm probably going to erase these. Whoops, sorry. But we have 30 degrees here. Okay, we have 30 degrees here, 30 degrees, 30, and 30. So we see that we have 1, 2, 3, 4, 5, 6 slices of pizza. Okay, and I talked about slices of pizza quite a bit before spring break. So we are going to look at dividing our semicircle, which is pi, by 6. So we have pi over 6, but then this is where we count by pi over 6's. We ignore the 45. So what is 2 pi over 6 equivalent to? Reduce it to pi over 3. And then 3 pi over 6 reduces to 2 pi over 2. And then 4 pi over 6, because 4 and 6 are even numbers, that reduces to 2 pi over 3. Okay, and then 5 pi over 6 cannot reduce, so we can just write that as is, odd and even number. And then we have 6 pi over 6 is pi. From here, we continue on. Anything in the bottom quadrant, I told you before spring break, is the numerator is going to be greater than the denominator. So now we have 7 pi over 6. Then 8 pi over 6 reduces to 4 pi over 3. 9 pi over 6 reduces to 3 pi over 2. Then we have 10 pi over 6, which is 5 pi over 3. And then 11 pi over 6. Then what would we have next? 12 pi over 6, which is reduces to 2 pi. That is a full circle. Now we need to take care of our 45-degree angles. Well, how many 45s fit into 180? Well, 180 divided by 45 is 4. So that can remind you that we are taking our semicircle of pi and we are dividing it by 4. Now, if you like the counting method, we go back up to our y-axis, which is 2 pi over 4 reduces to pi over 2. Then we have 3 pi over 4. We have 4 pi over 4, which is pi, and then our numerator gets larger than our denominator for 5 pi over 4. Then we have 6 pi over 4 is the bottom below on the y-axis, and then we have 7 pi over 4, and getting us to 8 pi over 4, 8 divided by 4 is 2, so that gets us back to our full circle. All right, so we've filled in everything. Now we're thinking about the actual location of these points on the unit circle. Okay, these points, if you recall, are actual XY coordinates. Okay, now the key idea is when we're looking at XY coordinates, okay, we know that X gives us the cosine of the angle that we're dealing with on the unit circle, And we know that y gives us the sine of the angle on the unit circle. Now from there, we can just focus on this first quadrant and then carry it through, because we know that the signs are just going to change based on plotting points. So in the first quadrant, we know that the cosine and the sine are both going to be positive, and nothing is going to be negative, okay? So we think of our special right triangles. This is where those numbers came from. So if we use our special right triangles, then we know, okay, we're thinking long, short for the 30 and the 60. I'm not going to do this for every angle, but to get to the 30, we're going to go a long distance and then a shorter distance up. Okay, so the long distance with our 30, 60, 90s is root 3 over 2, and that's just something you have to memorize, and the short distance is always 1/2. So that means that the cosine is root 3 over 2, so the cosine of pi over 6 is root 3 over 2, and then the sine of pi over 6 is 1/2. Okay, now from here then, I'm going to focus on the 60-degree angle, because now to get to 60, we're going to go short, long. So it's literally the same triangle, just flipped. So first, our x value is 1/2, and then our y value is root 3 over 2. In other words, the cosine is 1/2, and the sine is root 3 over 2. Remember, I always say x comes before y, c comes before s in the alphabet. That's how we can memorize. Okay, now let's go ahead and look at our second quadrant. Okay, so in our second quadrant, remember, cosine is x, and we have to go backwards, so the cosine is going to be negative, and then what is going to be positive still? The sine, because we are still going in the upward direction when we plot the points. So we can go ahead and look to get to 2 pi over 3. It's going to be short, long. So the short side of our 30 and 60, 90 triangles is 1/2. For some reason, I can't make my 2, okay? And then the long is root 3 over 2, and then I always just go back in and say, oh yeah, my cosine has to be negative. So then if we go to our 5 pi over 6, it's long, short, so we start with a root 3 over 2, and then we have our 1/2, and oh yeah, my x value has to be negative. Okay, now I had gotten a little ahead of myself, but I did want to finish quadrant 2 because we forgot the easiest part, which are the axis markers. Okay, so these points here, 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 and then the 270 degrees. So if I go ahead and look at what those would be, okay, we know that the radius measure of the unit circle is 1. So from the origin to get to 0 degrees, I have to go out 1, but I go up 0. The opposite is true on 90 degrees, so I go out 0, up 1. And then from the origin to get to 180, I go back 1, so negative, and then up 0. And then to get to 270, I go over 0, but then I have to go down 1. I love those quadrant markers. So now let's go back and finish the first semicircle, which is just the pi over 4s, which I like. They're easier because guess what? The sine and cosine are the same length. So that length, you have to memorize it, is root 2 over 2. So root 2 over 2, root 2 over 2. We love the first quadrant because both are positive. Now it's the same exact triangle for 3 pi over 4, root 2 over 2, root 2 over 2. But I have to go backwards on my x direction, so that x value, that cosine, is negative. Okay, so now all the values are the same. Let's go ahead and do our 45 degrees because we're on that kick right now. So if we look at 5 pi over 4, the middle line is always relates to your 45 degree angles. So we have root 2 over 2, root 2 over 2. But what do we know about the third quadrant? The third quadrant has both the cosine and the sine as negative. Okay, so we have negative, negative. Oh man, I just wrote that in the wrong section, so please erase if you followed along with me. I was just not acclimated. Okay, it should be the middle set of parentheses, so we have negative root 2 over 2, negative root 2 over 2. Okay, then we go to the fourth quadrant, and in that fourth quadrant, we see that we're going to go over in the positive direction, so cosine is positive, but then sine is negative. Okay, so we have root 2 over 2, root 2 over 2. That's our everything related to 45, 45. Okay, and then we see that our sine is negative, so we have to put a negative on that y value. So the sine of 7 pi over 4 is negative root 2 over 2. We are almost there. Hang with me. Okay, so now we are looking at our 30, 60, 90 triangles. So now if we go over and down, we're going to first go long and then short. So the cosine of 7 pi over 6 is the bigger number of root 3 over 2. And then we're going to go short, which is 1/2. So we have negative, negative in that third quadrant. And then it's obviously going to be flipped for 4 pi over 3 because we are going to go short long. So we have 1/2 root 3 over 2. And then we have negative, negative. In that fourth quadrant, okay, we start by going short long, and you can also look at it as a reflection of 240 degrees onto 300 degrees. So we have 1/2, and then we have root 3 over 2. And we have a negative in that sine. And then the opposite is true, long, short. So we have root 3 over 2, we have 1/2, and then we have that negative on our sine. So that completes our unit circle. You need to be able to do this on your own. So if you have time today, I would recommend either get out another blank sheet of paper and rewrite all of this without the video, or you can go ahead and print off another copy and try to fill it out yourself. Okay, so the other thing that I quickly want to talk about before I let you go is, is the kind of too long with your homework for today, which is a worksheet. Okay, so you're going to be doing numbers 1 through 18, but one thing we need to become good at is converting degrees to radians and radians to degrees. Okay, so I do want you to read through the examples. I'm not going to bore you with those, but I really like the examples because they show you the conversion factor. Okay, so basically it says if you are converting degrees to radians, then you can just simply multiply the degree measure by pi over 180. Okay, you can see them doing it here, and that will get you the radian measure. So we know, ultimately, that 210 degrees is equal to 7 pi over 6 radians. So it's really nice if you remember the conversion factor. However, if you forget, I taught you this before break, is you can just set up a proportion. We know that pi is equivalent to 180 degrees, so we want to know what radian measure is equivalent to 210 degrees. You have to put same unit in same places, and then you can use cross multiplication. But sometimes this cross multiplication method, the algebra can get messy, so it might be nice just to know that you always multiply your degrees by pi over 180. Okay, that's a math fact, a trig fact that we need to know. Now, what happens when you're changing radian to degrees. So now we're kind of doing the reverse by taking 3 pi and we want to convert it to degrees. Well, this is the conversion factor for degrees. How do you remember it? If you're given radian, okay, originally, then that measure is on the bottom. If you're given degrees originally, then the 180 is on the bottom. So from here, you can see that when you multiply fractions, the pi's are going to cancel out. So you're going to do 180 divided by 3, and you are going to get this value of 60 degrees. Okay, so walk through these a little more slowly with on your own. This is attached to the worksheet, but then you are going to be doing the practice problems here. Please make a valid attempt and try not to just rely on your calculator when kind of working on some of these. I guess not all of these would the calculator really help you. But then I really want you to focus on, okay, finding what angle pairs with the coordinate pair given. And obviously you can look at your unit circle, but I would encourage you eventually to try to maybe do this without looking at the unit circle first and then checking yourself. Okay, now the final thing in your lesson number 1 instructions was to play a game, okay? And I know some of you guys will be tempted to skip this, but I would utilize this game not just today, but when you have downtime, because I am serious, you guys, you need to memorize the unit circle. So if you scroll down about halfway through the page, okay, it says start game, and you have to play around with it a little bit, but you see all these blanks. For instance, the starting point for my game says, where is 7 pi over 4? So you're thinking to yourself, okay, well, I know at 180 degrees, that's 4 pi over 4. So then I have 5 pi over 4, 6 pi over 4, 7 pi over 4 is here. Okay, and then if you get it right, it's green, and then it moves on. Where's 7 pi over 6? Okay, so there's some weird questions, so you kind of have to mess with it a little bit, but I would take advantage of this because it's going to really help you memorize where things are. So, with that being said, I think I am done with the lesson video for today. If you have any questions, please don't hesitate to reach out and email me. And once you're done with all of the work, please make sure to upload it to the exit ticket so that you can get credit. And then you can move on at your own pace to lesson number 2. All right, I'll talk to you guys later.